All right. Hi, everyone. Welcome to our talk at amsterDOT. So for the top topic of the talk, we are going to be taking a deep dive into Moonbeam's EVM compatibility. So first, allow me to introduce myself. My name is Henry Duong. I joined the Moonbeam DevRel team in the summer of 2021. I first experimented with Substrate in 2018 after I saw the demo from Gavin Wood at the Web3 Summit, where he was able to create like a custom blockchain from scratch in like 1 hour or so. So prior work, I worked as a software engineer for Microsoft as a part of the Visual Studio team. And for my undergraduate, I studied industrial engineering at UC Berkeley. And I'm currently working toward a Master's of Science in CS from Georgia Institute of Technology. So I'm currently based in Taipei, but I am from Beijing. So first, let me give you guys a quick overview for the structure of this talk. So first, I will give you guys kind of like a quick overview of what Moonbeam is. And then after that, the main kind of content of this talk is going to be broken into 3 parts. And the first part is going to be about frontier. And then the second part is going to be about our unified account system. And then the third part, we're going to talk about our support for EIP 1559. Okay, so first of all, what is Moonbeam? So we are an Ethereum compatible smart contract parachain on Polkadot. That means that we are built with the Substrate framework. But wait, because we are talking about EVM compatibility, why is this important? Because underneath everything, Moonbeam is very much a substrate chain. So a lot of this talk should be taken within that context. We are very much creating an EVM environment within a substrate framework. And that is what makes it tricky, but that is also what enables a lot of like awesome possibilities. So we are fully compatible with Go Ethereum's JSON RPC endpoints. So what that means is that we basically emulate Ethereum at the RPC layer. So like this point is quite key, and we are going to expand on this during the frontier section of this talk. So the next part is we have a unified account system, which means that we use the same address format and the same signing scheme as Ethereum. So we are going to have a full section on this later. So I'm not going to go too much in depth now for this one. And then we have full integration with Ethereum dev tools, and also with like commonly used Ethereum infrastructure. So this kind of goes back to our previous point about Web3 RPC endpoint support, but it's worth stressing this because as a developer-facing platform, how user-friendly and robust your tool chain is one of the most important things. And right now, the Ethereum ecosystem's tooling is well ahead of everyone else. And that makes EVM compatibility a huge boon for any ecosystem that is looking to gain traction with devs. So in a lot of ways, Moonbeam unites the best of Ethereum and Polkadot. We marry the security, efficiency, and interoperability of Polkadot with the configurability and composability of Ethereum smart contracts. So you might ask, why are you trying to create an Ethereum compatible environment on Polkadot? And the answer to that is, it's because Ethereum compatible chains are seeing some of the highest user growth rate, and they're also seeing some of the highest gains in traction. So in the graph on the right, you can see that Ethereum compatible chains are actually growing at a higher rate than Ethereum itself. So that trend might change at some point, but as of current, this trend is still true. And as you can see on the left, our sister network, Moon River, was one of the fastest growing chains for the number of full-time developers in 2021. So who is currently using Moonbeam? By leveraging our EVM compatibility and our partnerships, we were able to bootstrap our ecosystem relatively quickly. As you can see, we already have over 80 DApps and protocols launched on Moon River and on Moonbeam, and they're all across a wide range of categories. And some of these are very well-known projects from Ethereum, and such as Curve, Lido, SushiSwap, Chainlink, and so on. So we believe that Ethereum compatibility not only is helpful to us, it also helps the entire Polkadot ecosystem, and for the following 3 reasons. One, because Ethereum and EVM currently, they have the largest ecosystem. By providing an easy on-ramp for existing project and devs, we create a way for these applications to quickly onboard into Polkadot. And secondly, all of these pallets that enable EVM compatibility on a substrate chain, such as Frontier, they're all fully open source, which means that any substrate chain can include these pallets, and they will be able to use Ethereum cell contracts. And the third thing is that by having EVM compatibility, we also offer devs a wider choice of tools, because now they can also use Ethereum tools to create their dApps on Polkadot. So, as I mentioned before, we believe this is very key for gaining adoption. So the next question is, how do we bring Ethereum compatibility to a substrate-based chain? And what we are going to talk about in the next part it's going to be about Frontier. So Frontier is made up of several smaller pallets, and they're called, and they include pallet Ethereum, include Frontier RPC extension, and they also include pallet EVM. And these pallets, they all serve different functions. So the Frontier RPC extension provides Web3.js compatible RPC layer. And then pallet EVM, it emulates Ethereum blocks and storage, and it handles Ethereum style logs and events. And then pallet EVM is the access layer between Substrate chain runtime and the EVM implementation in Rust. And so we will be looking at some of these parts more closely over the next few slides. So the first thing that we're going to need, we are going to need an Ethereum virtual machine. And luckily, one already exists, and that was written by Parity's Waytown. The EVM that we use in Frontier is called the Sputnik EVM, and it is fully written in Rust, and is highly efficient, and it was originally written for Ethereum Classic, but now is used in a lot of other EVM chains. But the question remains, how do we connect an EVM to the Substrate runtime? So the answer to that is we use pallet Ethereum. So Frontier contains a pallet called pallet Ethereum, and this pallet introduces a new type of extrinsic, and that type of extrinsic is called the unsigned extrinsic, where users can submit a raw and unmodified Ethereum transactions. So if you're not familiar with unsigned extrinsics, they are just basically like regular Substrate transactions, except that they are not signed by any one type of account. Since they're not signed, it means that we can accept the raw bytes of an Ethereum transaction, and then we can extract fields like sender, non-signature, gas price, or any other relevant data. And so once we have that information, we will pass that call into the underlying pallet EVM. The Ethereum pallet is also in charge of processing Ethereum blocks. And currently, Ethereum blocks are implemented as a part of the substrate state. So the next thing that we're going to be looking at is Moonbeam's unified accounts. So one of the biggest challenges of building an EVM compatible blockchain on Polkadot is rectifying the different account systems. So Polkadot and Ethereum's, they have different wallet address formats. The format used for Substrate is called H256, and the wallet address format used for EVM is called H160. And on top of that, we also need to maintain different account states. For instance, for like Ethereum accounts, there is no concept of free balance and reserve balance. Whereas for like a Substrate account, there are like 3 or 4 types of balance states. For instance, when you stake on Substrate, your account will have two types of balances. One is your free balance, and then your staked amount will become your reserve balance. Like these kind of concepts, they do not exist in Ethereum. And then finally, Substrate and Ethereum also use different encryption signing schemes. The signing scheme used for Substrate is called SR25519, and the one used for Ethereum is called ECDSA. So how do we bring a unified account system across these two very different architectures? So one approach, like one possible approach, it could be to map a Substrate account and key pair to an Ethereum account and key pair. However, by doing this, the user might require to switch their wallets or key pairs when they're interacting with different functions. So for example, under this model, to interact with the EVM, like if you want to transfer an ERC20 token, you would need to sign with your Ethereum key. But if you want to interact with Substrate features, like staking, the user would need to sign with their Substrate key. And if these key pairs are stored in like different wallets, or if they're stored in like different apps, the user would need to swap these wallets, or they need to swap these apps. And we believe this will lead to a fragmented user experience. So the approach that Moonbeam took is to use a unified account system, and which means that we use the same address format and signing scheme as Ethereum, which is the H160 address format, and EDSCA signing. So we basically had to revamp a lot of the Substrate account system and how the signing logic works. But we have been pretty happy with our end results. It basically allows our users to use one key to access features and applications within both Substrate and the EVM. And it also allows users to use widely used and very common like Ethereum wallets, such as MetaMask, to interact with all applications and features on Moonbeam. So now that we have talked a fair amount about Frontier and our unified account system, we're gonna shift gear a bit and talk about a more recent development within the last few months, which is about adding support for EIP 1559. So I assume like most people here have some idea of what EIP 1559 is, so this will be pretty brief. So what it is, it was basically a part of the Ethereum London hard fork, and it was activated on August 5th of 2021. And what it did, it completely revamps how Ethereum transaction gas is priced. So instead of miners keeping 100% of the fees included in a block, the fees are now split into a base fee and tips. And then the base fee portion of that is then burned and then the tips are given to the miners. So some of his goals are to make the gas pricing more efficient and also reduce overpayment. And it also wants to discourage miner fee manipulations, and it will also enable to allow higher throughput during peak usage by expanding the block size. So we added support for EIP 1559 in runtime 1200, and that was done in February of this year. So it was only like a few months ago. So to implement EIP 1559, we created a new pallet in Frontier, and that pallet is called the base fee pallet. So what it does is that this pallet will calculate the network base fee based on the fullness of the parent block. And then, so what it does is that it will set a certain target, which is normally set to 50%. And then the upper bound of it, it will be closer, it will go to the right, it will move closer to 100%, which means like it's like a full block. And then if you move to the left from the target, it will move towards 0%, which means like it's like an empty block. So currently, the Moonbeam network base fee is fixed at one gwei, but we're planning to enable the base fee to flow in a future runtime update. So the other new feature that we implemented in Frontier to support EIP 1559 is a new RPC method, and that method is called ETH fee history. And what it is, it's basically a fee oracle. Sorry. That will query for the effective fee range given a block range. And because this method is very computationally expensive, kind of similar to ETH-get logs, we had to implement a cache. And so we cached the latest block fees and also the previous 1,024 blocks that are ready to use with all the range of the fees. So 1,024 blocks is the maximum block range that you can queue for this call by spec. And currently, this method is used by MetaMask to estimate for fees of like EIP 1559 transactions that are sent on Moonbeam. So yeah, some of my final thoughts. So we plan to stay close to the Ethereum roadmap to ensure the highest level of compatibility with the Ethereum and with the EVM. But we believe that just being EVM compatible is not enough in a rapidly changing market. And we believe that the Polkadot ecosystem and the substrate features such as XCM are key differentiators for us. And we believe that Moonbeam will thrive when the Polkadot ecosystem thrives. So, which means that we very much believe in WAGMI, that we're all gonna make it. So we want to create a positive sum game instead of a zero-sum game, not just on our chain, but within the greater Polkadot ecosystem. Okay, so that is the end of my talk. Let me know if you guys have any questions. And here's some ways to get in touch if you want to learn more about Moonbeam. Yeah, and thank you very much for your time.